Alright guys, tonight we're going to look at word problems for chemical reactions. So what I would like you to do is take a moment, pause, and copy down this word problem in your notes. Got it? Good. Alright, so we're going to be working with word problems in our book, and we have to be able to pull out the important information. I'm going to tell you now, the word problems in your book are going to give you lots of distractors. That is a whole bunch of fluff about the chemicals and the chemical reactions that you don't need to know. When it all boils down to the last couple of sentences that give you all the key information you need. This example, aqueous potassium iodide reacts with bromine gas to produce aqueous potassium bromide and iodine gas, is what you really need to know. This is the meat of the chemical reaction. Our task with these word problems is to take the words and write a chemical formula equation from them. In order to do this, we need to figure out our reactants and our products. And right here it says that potassium iodide reacts with bromine. The reacts with serves as the plus sign for us. And that to produce potassium bromide and iodine. This and is our plus for the product side. We have to remember our formula writing skills in order to write the formula equation. So potassium iodide, using your periodic table, potassium gets a +1 charge, iodine gets a -1 charge. So when we crisscross, we get Ki for potassium iodide. So we write that. Potassium iodide, and we were told it's aqueous, right? Reacts with, there's your plus, bromine gas. The bromine is part of Brinkelhoff from last night's lecture, so we write Br2, and it is told to us that it's a gas. Now, when they react, they produce, there's our arrow, to produce or to yield is the arrow, and potassium bromide. Potassium gets a +1 charge. Bromine gets a -1 charge. So when we crisscross, we're going to get KBr and iodine gas. Iodine is part of the Brinkelhoff system, so we're going to put I2 with a G there and an AQ right in here. What's left is for us to balance. When we look at the reactant side, we see that there is one potassium ion, or one potassium atom. The product side has one, so we're good there. We have one iodine on the reactant side, but we have two iodine atoms on the product side because of Brinkelhoff. So we have to place a 2 coefficient in front of the potassium iodide. That then screws up our potassiums. So now we have to put a 2 coefficient in front of the potassium bromide. That works out just fine for us because we have 2 bromines for our elemental bromine gas on the reactant side, and we are balanced. This is how you write and balance a chemical equation from a word equation. Just like in the last example, I want you to pause for a minute and copy down this long word problem. All right, we're going to attack this word problem just like we attacked the first one. When aqueous sodium phosphate mixes with, here we have the plus sign, mixes with, okay, so sodium phosphate plus aqueous calcium nitrate. We have sodium nitrate solution and calcium phosphate precipitate being produced. So there is our set of products. The word and here gives us our plus sign. Now we need to write out our formulas. Because we have all ionic compounds and sodium and calcium are both in group 1 and group 2, we need to crisscross our charges. We don't have any Roman numerals to worry about here. These are all type 1 ionic compounds. So let's see what happens. Sodium here, guys, is a +1 charge. Phosphate is a -3 charge. When we crisscross, we're going to get Na3PO4, and that's aqueous. And that mixes with, that's our plus sign, calcium nitrate. Well, calcium is a +2, nitrate is a -1. So when we crisscross, we get Ca, open parentheses, NO3, 2, and that's aqueous. Let me make it a Q, not a G. Then we are given a list of products, so that indicates to us it's time for an arrow. We have a sodium nitrate solution, Na plus and NO3 minus crisscross to produce NaNO3. We're told it's a solution. That tells us it's aqueous. And is our plus sign, calcium phosphate. Ca plus 2, PO4 minus 3 gives us Ca3, PO4, 2. And that's a precipitate, so we can write a solid here. If you notice what happened here, this is something to kind of check out. Our ions from our reactants switched. So our sodium and our nitrate combined to make a product, and our calcium and our phosphate combined to make a product. That's going to become really important when we get to chapter 7. But for right now, let's focus on balancing this guy. If we start with the sodium, we have 3 sodiums on the reactant side, but only 1 on the product side. So 1 times 3 is 3. If we look at the phosphate and see that the phosphate survived, we have 1 phosphate to begin with, and we have 2 on the product side. So we have to put a 2 coefficient on the reactant side to get the same number. That then is going to mess up our sodium ions. So we now have 2 times 3 is 6 sodiums. So we cross this off and we put a 6 here instead. We have 1 calcium on the reactant side and 3 on the product side. 1 times 3 is 3. So we put a 3 coefficient in front of the calcium nitrate. Now we have a choice to make. Do we see that we have 3 times the 2 nitrates for a total of 6? Or, let me put the 3 back. Do we see that we have 2 nitrogens times 3 is 6 nitrogens? And over here we've got 6 nitrogens, so we're good. We also got the 6 sodiums, right? We also have 6 oxygens times 3 is 18, and 6 times 3 is 18. So we're good with the nitrogen, or the oxygens, excuse me. We now have a completely balanced chemical equation that we wrote ourselves from a word problem. Tomorrow in class, we're going to practice this with several problems from our book.